by dx. Today we will see play with the graphs. There are some graphs that we need to analyze in the chapter of motion. A lot of topics we have covered as you saw in the previous classes. Now uh, we will play with graphs, and you will observe constant motion, uniform motion, a lot of motion. For example, acceleration motion, velocity, speed, AXT graph, VT graph. All this will be covered in this lecture. Here I wrote dy upon dx. What are you understanding by this? D over here means differentiation. Y is axis, x is also axis. Here you need to understand y will change according to x. Whatever will be value of y, it will change with respect to x. Okay, if y is increasing, so x will also increase. Okay. For example, value of y is 4 and value of x is 2. Next time value of y will become 8 and value of x will become 4. So both variable will go together. Here dy upon dx means this is a slope. We will get a slope and slope is known as a tangent. A lot of time you will listen tangent. Okay, in short it is written like a tan theta, or you can say tan theta. So tan theta is just a slope, and slope is what dy upon dx. This is in language of depreciation. Okay, depreciation, because we are different. We are doing depreciation. That's why. My focus is I am saying dy upon dx is equal to slope. Again, it is equal to tan theta. That's it. Over here, we will replace y by x, and then we will replace this x by t. That is how some variables will be replaced. V upon t, x upon t, like that. So t is a time, x is a position, location of a particle, and v is a velocity. So when we are taking v, it means we are finding acceleration. Just have a look. As I said you, when you will replace this y by x, and this x which is in denominator by t, in that case what will happen? This is your slope. So d upon dx upon dt, this will give you nothing but velocity. Dx upon dt is a velocity. Okay, or you can say v. Just we replaced this y by x and this x by t. That's it. And this became formula for velocity. Now, next for acceleration. What if you replace this x by b and t will be as it? In that case, what will happen? Our formula will become acceleration. So, for acceleration is nothing but dv upon dt. Just we replaced this x by v. That's it. And now it became what? Acceleration formula. So acceleration, in short, I wrote over here. It can be represented by a small letter a. Our focus is on graph. So remember, xt will give you which graph? Velocity graph. And vt will give you acceleration graph. Okay, acceleration graph. On graph you will realize like that. This is known as y, but here instead of a y, here you will add this x, and this will be our t. This graph is known as xt graph. Okay, because here this is x and this is a t. That's why this graph, name of this graph will be xt graph. If you replace this x by b and t is as it, because time is compulsory for both cases. So that's why t will be as it. Now this graph became acceleration graph, or you can say Vt graph. This will be known as Vt graph. Okay. So from Vt graph you will understand that we have acceleration graph. From xt graph you will understand that we have a velocity graph. That is how you will understand. Next point, next topic. One thing again I want to repeat. Distance and displacement. One thing will be always fixed, which is distance will be what? Always positive. Okay? Positive. But in the case of a displacement, it can be negative, it can be positive, it can be zero, it can be upward, it can be downward. Because displacement provides direction. Okay? So in the case of a displacement, everything can happen. But in the case of a distance, only positive will happen. Only positive will happen. And distance is a scalar quantity, as you know. Now let's draw some graphs so that we can analyze. These are some graphs. There are six graphs of dt. D stands for distance, T stands for time. Question is asking, is given graph correct or not? Let's see. As I told you right now, distance will be positive, it cannot be negative at all. So in the first figure, in the first graph, uh, it is like this. It is coming from upward to downward. So downward, it is going negative. That's why this is not possible. This is not possible. Now in this graph, starting point is this. This is the starting from origin. So of course it is increasing. In this case, this was a decreasing. Now in this graph, it is increasing. So increasing, which means positive. That's why this is a possible. This graph is possible for distance. Now same over here. It is also possible because this curved line is increasing. That's why. Now in this case, this one straight line is coming in two part, in this part and in this quadrant. So this quadrant is known as negative. So from here to till here, this is a positive, but when it comes to this part, this will be negative. So positive negative, it cannot happen with the distance. So this is not possible. Now in this graph, it is increasing, then decreasing. This is also not possible. This is also not possible. Because decreasing is not for distance. Now here, it is increasing over here, then this is constant, then again it is increasing. There is a not decreasing part, decreasing view. That's why this will be possible for distance. That is how you will tell that given is a given graph possible to distance or not. That is all. If you are able to observe that there is a decreasing part, then you can say that yes, this given graph is not possible because there is a decreasing view part. Okay, just have a look. Now next. Next is how to find that slope is negative or positive. how to find that slope is a negative or positive. That is what we are going to observe over here. Let me draw a Cartesian plan. Try to observe this two graphs. What's the difference between them? Look, question is question is how to find negative slope, how to find positive slope. So there is a logic behind it, and logic is if graph is like this, okay, you can see tangent. Just draw a tangent. If you have a curved line, you can just draw a tangent line at that point. So you will get like that straight line. Now your work is to observe that theta. What is a theta? What is the angle? What is angle? Okay, angle formation with this tangent. If value of angle is coming which is less than 90, it means your slope is positive. Condition is value of rotation should be less than 90. In that case, your slope will be positive. Are you understanding? So in this case, this is not a perpendicular. You are familiar with it. This is not perpendicular because perpendicular, in the case of a perpendicular, we get 90-degree angle. But this is not a perpendicular. And you can also find that this is a less than 90. That's why you would say that this would be less than 90. So 90 and theta. So less than, and this is our theta. It is telling you that our theta value of a theta is less than 90. So in that case, as I told you, this slope is positive. Slope is positive. That is how you will answer. Condition was just value of angle should be less than 90. That's it. And if you have curved line, in that case, just draw a tangent line at that particular point. Then you will get tangent, this type of a tangent line. Then you will get clarity to find value of angle. Okay. Now in this graph, anti-clockwise direction is anti-clockwise. So this is making, let's say, it is not perpendicular, but we can say that this is greater than perpendicular. Rotation over here is greater than 90-degree because this is perpendicular and it is coming this side of the perpendicular. That's why this is greater than. So here our angle is more than 90 degree. So if your angle of a tangent is coming more than 90 degree, then you would say slope is negative. slope is negative. Okay. Angle can be 126, it can be 120, it can be 190, it can be 220. So all these numbers are greater than 90. That's why this type of tangent will give you negative slope. In the case of acute angle, angle can be 45 degree, angle can be 35 degree, it can be 60 degree. So all these numbers of a tangent will give you positive slope. Okay. So this was about how to find negative slope, positive slope. In simple sentence we can say, if angle is less than 90, our slope is positive. If angle is greater than 90, then our slope is negative. That's it. Now next part. Let's use this on a curved line. On curved line. There are two graphs that are different from the previous. Question is to find slope. Is the slope or negative, positive, or zero? Or zero. So let's find our graph is xt graph, not vt. Xt graph is what? Velocity. Velocity. Vt graph is acceleration. Now, increasing view. Okay, let's draw what tangent line. So at this point, our tangent will be like this, isn't it? At this point, our tangent line will look like this. In this case, this angle is acute angle. This is our acute angle. So acute, which means less than 90. So that's why this will be positive slope. Over here, this is positive slope. Okay? Because angle is acute. Now, at the top bottom over here this is a turning point. This part is known as a turning point. So, it is a constant. If you draw this tangent line, you will get a horizontal line. So horizontal or vertical line is a constant. Constant means fixed, zero. In that case, we will consider constant number as a 0. So here velocity is not positive, it's not negative. Velocity is a 0. Okay, so here velocity is a 0. Now, what about this? What about this? It is a little bit greater than 90, little bit, not too much, but little bit greater than 90. If it is coming in the part of a greater than 90, then it will be also considered as a negative slope. This is our negative slope. That is, so this is increasing, this is a decreasing, and this is what here velocity will be 0. Here velocity is increasing, vehicle is increasing, a speed of a vehicle is increasing, but here a speed of a vehicle is decreasing. So if a speed of a vehicle is increasing, so our slope is positive. If a speed of a vehicle is decreasing, our slope is negative. If a vehicle is not moving, so velocity will be 0. Now in this case, there are 4 points, not 4 points. This one, this another, this third, this fourth, and this fifth. I think this fifth. So our tangent for this point will look like that. So this is acute angle. That's why this is a positive. V is a positive. So here velocity is increasing. Meaning of this positive is velocity is increasing. Our graph is xt graph. So that's why I am saying velocity is increasing. Now at this point, as we saw in this figure, that if tangent line is what, horizontal or vertical, in both cases velocity is 0. Okay, because horizontal or vertical both are constant motion, uniform motion. So that's why velocity will be 0, or it can be called as a constant motion. Now this third point, in this part we are getting like this tangent line, and our work is to find the angle of this tangent with this line. So of course this is an obtuse angle, not acute. So this is obtuse angle. Obtuse angle is greater than 90. So greater than 90, angle is greater than 90. So in that case you will say our slope is negative. Okay, this is a negative. What about this? Here again we are getting horizontal slope. That's why this is a 0. Okay, this is 0. I hope you understood something. Now, if you want to know what about this point and what about this point, in that case, here just to draw a tangent line, you are getting obtuse angle, so this will be negative slope, and in that case, just to draw a tangent line, you are getting positive slope because of the angle is acute. That's why angle is acute. Now next figure. Now next figure. This is the next graph. In this case, we have to find average velocity. When it comes to average velocity, we find the total. So question is find average velocity. Time is 0 to 10. Time is 0 to 10. So this is our figure with this question. Find average velocity when it comes to average velocity, not instantaneous velocity. For instantaneous velocity, we use tan theta formula. For average velocity, we will use different formula. So different formula will be, this is a symbol for average velocity. This is symbol, close, open, close, open. Only if you write the V, then this will be known as instantaneous velocity. When you will use this is simple, this will become our average velocity. So this is equal to final velocity, this final and initial. Okay, this final and initial. So this is our x and this is our t. Final minus initial. Initial upon total time. Okay, so time is 0 from 0 to 10 seconds. So time our will be 10 and my final minus initial. So final point is this b, which is 40 and initial is. You will use this type of formula when question is saying find the average velocity then. But when it comes to instantaneous velocity, as I told you, formula will be different. So formula is nothing but dx upon dt is equal to velocity. But here, as we are observing, that formula is average velocity is equal to minus final minus initial upon t. Okay. Average means total. So final location of this particle is where? At this 40. And initial location of this particle was over here, 10. And this particle took how much time? 10 seconds. Then Simplify this. After simplifying this, I hope you should get 6. Otherwise 10 minus 5, this is coming 10 seconds, so 30 upon 10. Okay, so 40 minus 10, this 40 and then minus 10. So from initial time is 0 to 10, but from this 10 to 40 time is 5. Time is 5 from 10 to 40. From 10 to 40. So our average velocity will be 6. So meaning of this is 6 is 6 meter per second. Average velocity was 6 meter per second. Okay, meter per second. Now, if you want to find tan theta, so in that case, this is our P and B. So P is nothing but 30. This will be 30 because 40 minus 10, 30, and 30 upon this will be your hypotenuse. So 30 upon 5 will be your 6. So 6 meter per second. So over 30 upon 5. In both cases, you are getting same answer, which is 6 meter per second. Whatever you have two options. Whatever option do you want to use, you can use. So from this, velocity is coming same, and from this tan theta, answer is coming same. 6 meter per second tan theta. So how did we write this 30 upon 5? So this perpendicular upon base. That is how we wrote this 30 upon 5. Okay, to calculate this hypotenuse. So hypotenuse is this much. So with this much velocity, our this particle was moving from here to till here. Okay, this is the meaning of 6 meter per second. Try to understand this graph. This graph here. This was location of a particle initially, and now location of a particle is over here at 40. So all these are locations. Okay. So this is a time. This is a time. Okay. 10 minus 5. Our time will be 5. And now, as you can see, this 5 is coming over here and 10 is coming over here. So we want to find this part. So that's why time will be 5. Why should we take 10? So 10, if you take 10, so you are taking from origin, which is uncompulsory, which is unnecessary. We need this 10 minus 5. So time over here is 5. And this distance is at 40 minus 10, which will come out as a 30. 30, okay? Uh, this distance is 5 and this much, this is the distance is a 30. From this upon this you will get this hypotenuse, value of a hypotenuse, which is a 6 meter per second. Okay? So question is the same from here to till here. If a particle starts moving from origin and it reaches till the 40, then it will take 10 second. 10 second. But what is happening over here? This only question is asking location of particle is over here, over 10, and it reached till the 40. So between this, what is our average velocity? That is what the question is asking. Question is not asking from the origin, no. So we know that total distance would be 30, but what about the time? Question is what about the time? So time we will get from here 10 minus 5, this point, this is initial and this is final. So time from here to till here 10 minus 5, from here you will get the time. Okay. Okay. Now our tangent line is looking like that. This is a tangent and amount of rotation is at 30 degree. Amount of rotation is at 30 degree. You can simply use formula which is a tan 30. If you don't have final value of a final and value of a initial, in that case you can use only this tan theta. But condition is you should have value of angle. So from this you will get with how much speed something can go along this line, with how much speed. So you will get when you will use this formula. So tan theta is nothing but 1 upon root 3. When you will simplify this, you will get number which will be in decimal. Now let's say our angle is 45 degree. Our angle is 45 degree. So tan 45 will become nothing but 1. Cot 45 is a 1. Our focus is on answer. This answer came which is 1. What is the meaning of this 1? So it is telling you with this much speed, with this much velocity, vehicle will go along this line which is a tangent line. Okay, rather than using the average velocity is equal to final minus initial upon time, you can use this tan theta. Okay, tan, because we are using tan theta, not sine, not cos, not sec, not cosec. Only we are using tan theta because tan theta is known as a tangent line. This is a slope. That's all. there are three angles which are making with this straight line. There are three angles. Look at over here. Let's start with this angle. Here you can see it is, this is in first quadrant. This angle is in first quadrant. It doesn't matter. Angle is how much? 37 degree. So if you use a tan, okay, if you use a tan 37, as you can see our line is straight. This straight line is known as a constant as well. Okay, so velocity will be constant. Velocity is constant. So tell me what will be value of a tan 37 degree. So value of a tan 37 degree you will have to keep remember in your mind. So tan 37 degree will be nothing but 3 upon 4. Okay, 3 upon 4 meter per second. When you will simplify this, you will get in decimal answer, in decimal number. Okay, till here this is our answer, but if you want to simplify this, then you will get your number in decimal. Okay, so tan 37, value of tan 37 is a 3 upon 4 meter per second. So meaning of this is what? With this much velocity, vehicle is moving from here to till here. It can go upward, it can go upward. But remember, this is a here line is a constant. That's why with this much velocity, it will keep going. Now, what about this? What about this? Angle is the same, 37 degree. So angle is the same, 37 degrees. So value will be same, 3 upon 4. So for this also 3 upon 4. In this case, I know this is coming in 3 quadrant. This first, this second, and this third. It doesn't matter. Angle will matter. So 37. Angle is at 37. Amount of rotation. Amount of rotation of angle is at 37 degree. As we know that 37 degree is nothing but 3 upon 4. I have written over here. This is value of a tan 37 degree. So in 3 cases, value is coming same. So calculation is, in the 3 cases, velocity is the same. With the same velocities, all 3 particles are moving. Next is a little bit different, but not too much. This is our computation with graph. Question is asking what would be displacement and distance, and graph is given like this. As we can see, there is a particle which is starting from here and it is going downward, then again it is going upward. This is how we are given. So it starts from 10 and then it is coming over here, 10 minus 10. Don't look like this. What is an initial point and what is a final point? That's it. So from t is equal to 0 till the t is equal to 10. So time is over here. This is our t and this is 0. Where should a particle is starting from here? So initial point is this and final is this. So final displacement is equal to final minus initial. So value of final location is 4, which is in positive. Value of this initial location of a particle, which is a positive 10. So negative positive will become negative. So displacement is coming nothing but minus 6. Okay, that is how you will find. Now distance is nothing but this is a total sum of a total length covered by something. So it starts from here 10. Okay, 10. Okay, 10. Now it is going upward. So 10 and then 4. So it will become 14. So 14 plus 10 is nothing but 24. So 24 is the total distance. But when it comes to displacement would be minus 6. Displacement would be minus 6. we have to find acceleration in this six graphs. Acceleration. So remember, for acceleration in the case of xt graph, acceleration if it is looking like this. So in that case, our acceleration is positive. If graph is looking like this, so our u is positive, and this opposite of u is a negative acceleration. So I have told you how to find negative velocity, positive velocity. So this will depend on angle of a tangent line. So in this case, over here, this v is a negative, but acceleration is positive because this is a like this. That's why u. Okay. So at this over here, acceleration over here, our tangent will be horizontal. That's why acceleration and velocity both will be 0 over here. A will be 0. Okay. And over here, this acceleration is positive, but velocity is negative. Velocity is negative. In this case, this is point and this is point. So first of all, velocity will be nothing but, you can see our tangent line is coming with acute angle. That's why velocity is positive, v is positive, but a is a negative because this is the opposite of u. That's why. So acceleration is negative. It is not compulsory that if velocity is coming positive, then acceleration will be always will be also a positive. No, it will not happen all the times. So now, what about this point? So over here, this is nothing but let's say it is forming like this. So in this case, we are getting acute angle. So velocity is positive and acceleration will be negative. Okay, that is how you will find negative, positive acceleration and velocity. Next we have this graph. So this is point and this is point. So our for velocity graph will go like this. Tangent will go like this. So of course angle is obtuse. So that's why v is a negative, and acceleration is also this is a negative because it is the opposite of u. That's why. Now in this case, v will be negative because angle is obtuse, and a is also negative because of this is opposite of u. Now in this graph, there are 2 points. Let me do. There are 2 points. So an angle of a tangent is acute as you can see over here. So that's why in both cases v will be positive and our v is again positive. Now what about the acceleration? Acceleration can be different. It can be equal. So acceleration would be nothing but positive because this is a u. That is making a u. So this is positive. Acceleration over here is positive. Now in this graph, let's draw 3 points. 3 points. There is a twist in this graph. Here our tangent line is like this, and this tangent line is giving acute angle. That's why velocity is again positive, but acceleration is negative because this is opposite of u. That's why acceleration is negative. Now at this point, uh, tangent line is a horizontal constant. So that's why a will be also 0, v will be also 0 because of a constant tangent line. That's why. Okay. So next point is over here. In this case, angle is obtuse angle. That's why velocity will be negative. But acceleration will be also negative because of this is the opposite of u. That's why. Okay. Because of this curved line is making opposite of u. That's all. Now this last, this one point, this third point, this fourth point, this fifth point, this is sixth point. There are 6 points. If you draw this, you will get like this. In this case, angle is obtuse, so velocity will become negative. Acceleration is positive because it is a u, curved line is a u. Now over here, velocity again is negative, acceleration will be positive. Over here, velocity and acceleration is 0. Here, this is a tangent line. Over here, it is a vertical line. So, vertical line and horizontal line both will give you 0 velocity and 0 acceleration. So, V is a 0, A is also 0. Over here, V is a positive, A is also positive because of this is U. This is U. That's all.